Good evening, friends. Welcome to day 10 of the Six Sigma Masterclass Elite sessions. So, as I told you yesterday, we will have the training sessions initially. So, we will complete the control phase and we would have covered the common GB and BB curriculum. And then I'll give you a brief about the project exercise. And if time permits, we'll also do a quick revision of the statistical exercises that are likely to come as questions in the Greenbelt final assessment. And then the final 60 minutes, you will be attempting the Greenbelt final assessment. So that is going to be the agenda. So let's get started without any delay. Let me just share my screen. So yesterday we were discussing about the deliverables under the improve phase, which is the fourth phase in the DMIC approach. So improve phase, we will start by brainstorming for solutions. So in the analyze phase, we would have started with brainstorming for causes. So the improve phase, we will start with brainstorming for solutions. So we'll not come up with just one single solution, we'll generate alternate solutions for the simple reason, if the primary solution is not going to yield the required benefit, we will always have the backup solution which can be implemented immediately. Otherwise, we might have to conduct the brainstorming session once again, right, which can be avoided. And then we will categorize the solutions using the affinity diagram. And then we will identify or we will prioritize implementation of solutions through Q matrix or effort versus benefit matrix. And then we will identify a pilot area within the process where we would be implementing the solutions. And then we will calculate the improved CTQ metric performance. So we will also validate whether we have attained the project goal as mentioned in the project charter. And then we will also validate by performing relevant hypothesis tests the improvement made. And then we will also calculate the improved process capability, wherein we will calculate the improved sigma level as part of this. And then we will identify the risks associated with the improved process steps by performing an exercise called FMEA, failure mode and effect analysis. And then we will modify the process document and also construct what is called the 2B process flow. So the depiction of the process that needs to be followed in the future. And the most important thing, we need to train the employees, right, with regard to the improved process steps. And we need to get their buy-in, right? So unless and until we get their buy-in, it would be very difficult for us to sustain the improvement made, right? So in order to ensure that the improvement is sustained over a period of time in the future, so it's important that the employees who are working in that process follow the improved process steps, right? Follow as per the improved process steps. Otherwise, it will be difficult for us to sustain that improvement. And for this, we need to obviously get their buy-in, or we need to convince them that following the improved process steps would definitely yield lots of benefits for them, right? And once that is done, we can always scale up the solutions covering the entire process. And then yesterday we looked at a couple of tools which would help us to prioritize the solutions. The Pew matrix. So in case of Pew matrix, we will first come up with the criteria elements that you would consider for implementing the solutions. And then we will provide weightage for these criteria elements based on the importance you plan to give for these criteria elements. And then we will have the multiple solutions in different columns. We will rate all these solutions against each of these criteria elements in the scale of 1 to 5. So 1 being the criteria element is least favorable for that solution, and 5 being the criteria element is most favorable for that solution. And then finally, we will calculate what is called the total weighted score, which is nothing but the rating score that you would have given for a solution against a particular criteria element multiplied by the weightage that you would have already assigned for that criteria element. So once we total all these weighted scores, we will get the total weighted score, and whichever solution has the highest total weighted score will be prioritized for implementation. So obviously, if this solution is not going to yield the required benefit, then we will look at the next best solution. So the solution which has the next highest or the second highest total weighted score will be tried out, right? And then we also looked at how to perform this effort versus benefit matrix. Again, a very simple tool in order to prioritize the solutions. So effort versus benefit matrix will be in the form of a quadrant. So we would place all these solutions in the relevant quadrant, and then we will have effort on one side and benefit on the other side. So effort, we will have the categories as low and high. Similarly, for benefit, we will have the categories as high and low. So the solution placed in the quadrant low effort and high benefit will be prioritized first. The solution placed in the quadrant low effort and low benefit will be prioritized second, and the solution placed in the quadrant high effort and high benefit will be prioritized third, and the final one, high effort and low benefit solutions, will not be considered at all. And as I told you yesterday, it's important for us to identify the risks associated with the improved process steps, and for that we will be performing this exercise called FMEA, which is failure mode and effect analysis. Then this exercise is supposed to be done on a routine basis. So whenever we come up with a process change or a process update, so we need to perform this FME exercise. But then if I have not worked on this exercise so far for your process, it's always advisable to perform this exercise first, at least for the milestone process steps, so that you would be proactively be able to identify the risks associated with the various process steps and would be in a position to implement some preventive action, which is what we would call as the control measure, right? So otherwise, what will happen? So the risks will be pretty much in open, and the risk can actually create some potential damage. And once the damage happens, we all know how much it would cost for making the correction and also implementing the corrective action. So it's not only the cost part, but also the mental trauma that goes along with it. So it's going to be very tough, right? Making the correction and corrective action when a damage actually occurs. So it's always, better to proactively identify the process gap as a risk and then mitigate the risk by arresting the potential damage from taking place, right? So for that, we need to exercise this FMEA tool. So FMEA is a proactive tool, right? Because it would help us to identify the risks in a proactive manner, and it would help us to implement the preventive actions. So preventive actions are always proactive actions, right? So there are two types of FMEA as we can see here. One is the design FMEA and the other one is the process FMEA. So when we actually identify the risks associated with the product design feature or with a service output design feature, then it would be called as a design FMEA. So when we develop a product, right? So there will be various features attached to that product, right? So each feature might potentially carry some risk. So unless and until we probe and then find out if there is any risk associated with this feature, then we will not be able to clearly identify the hidden risk, right, associated with that feature, and will not be in a position to mitigate the same. One simple example would be the laptop pin, right? The plug which carries power to the laptop, right? If you look at those days, I've seen the pin will be protruding outside, right? So when the pin is protruding outside, when the laptop power is switched on, obviously the pin which connects the laptop end, if it is protruding outside, and if the user comes in contact of that metallic pin, it can actually give a shock to the user, which might even prove fatal to the user's life, right? So that's why, they would have actually insulated that part of the, product, right? So the pin would be properly insulated so that even if the user purposefully want to touch that pin, he or she will not be able to do so because it will be deep inside that insulated hole, right? So the outer portion will be properly insulated so that, when the laptop pin is inserted inside the laptop, so the user will not be able to come in contact with that metallic pin. So this is kind of a design FMEA that would have been performed, right? So like this, we can, probably think through various, design FMEA aspects, right? Uh, Pertaining to a particular product, right? But then when we are actually identifying the risks associated with the various process steps that you would execute in a process, it will be called as a process FMEA. So whether it is a design FMEA or a process FMEA, the template that we are going to use to kind of fill in all our findings will be a standard one, except for the first column. So in case of design FMEA, we will have the design features listed down in the first column. In case of process FMEA, we will list down all the process steps in the first column. That's the only difference. All the other column headers you would find in the standard FMEA template will be the same for both design FMEA as well as for the process FMEA, right? So we'll quickly look at the contents that are part of this standard FMEA template, and it will also give you an idea as to how to conduct this FMEA exercise, right? So if you are conducting the process FMEA, as I told you, we will have the process steps in the first column. So I list down all those critical process steps that we would execute in our process. And for a process step, we will come up with the failure mode. So this failure mode is actually the risk part. So the risk associated with that process step is what we would call as the failure mode. So if you look at the explanation, failure mode is nothing but in what all ways this process step can actually fail. In what all ways this process step can actually fail is the failure mode. And this is the risk part of it. So because of this failure mode, what is the kind of failure effect that we are likely to experience? So here we are only making some assumptions about the failure effect, probable cause, etc. Right? So all these things have not happened. So when it is a risk, all the assumptions will be made with regard to the failure effect, probable cause, etc. Right? So you're only assuming or we are only anticipating if this risk becomes a reality, what is the kind of effect that will be experienced due to this risk, right? So that is what we would sum it up under failure effect. So the ultimate impact that would be experienced because of the failure mode is what we would update under failure effect. And for this failure effect, we will provide a rating called severity rating in the scale of 1 to 10. So the failure effect is very, very severe that it might even result in loss of human life. Then I will provide a severity rating in the range of 9 or 10. But then the failure effect would potentially result in loss of business opportunities. Then I will give a severity rating in the range of 7 or 8. But then if the failure effect is not all that severe, I may even give a severity rating less than 5. So severity rating, the scale of 1 to 10 is given for the failure effect based on the severity of the failure effect. And in the next section, we will come up with the probable cause or probable causes which might actually trigger the failure mode. So the risk cannot happen on its own. So the risk will always be triggered by a single cause or multiple causes. So here we are using the term probable cause. Why probable cause? As I told you, the cause wouldn't have occurred, right? But there is an opportunity for this cause to occur. In that case, the risk will become a reality. So what is that probable cause which we need to attack, right? So what is that probable cause which would actually trigger this failure mode or the risk needs to be stated under this. And for this probable cause, I will come up with a rating called occurrence rating, again in the scale of 1 to 10. So if that probable cause is likely to occur more frequently, then I will give a higher rating for occurrence. At the same time, if that probable cause is likely to occur less frequently, then I will give lesser rating for occurrence. So occurrence rating will be given based on the likely frequency of occurrence of the probable cause, right? And the final section, we will have current controls. So what are the current control measures or the preventive measures that I have already implemented to mitigate this failure mode or the risk? So that needs to be updated under current controls. So what are the control mechanisms that I already have in place to mitigate this failure mode or the risk? And for these current controls, I will provide a rating called detection rating, again in the scale of 1 to 10. So if the current controls are not there at all, the current controls are not evident, right? Then I will provide a higher detection rating. But if the current controls are quite effective, then in that case, I will give a lesser detection rating. So based on the current controls, the effectiveness of the current controls, I will provide the detection rating. Control mechanism is not there at all. Higher detection rating. Control mechanism is very, very robust and highly effective. I will give a lesser detection rating. So once I have given the severity rating, occurrence rating, and the detection rating for a particular process step, I will calculate a metric called RPN. RPN, the full form is risk priority number, which can be calculated by simply multiplying the severity rating with occurrence rating and detection rating. So RPN is the metric which is referred as risk priority number, and this can be calculated by simply multiplying the severity rating with occurrence rating and detection rating. In fact, in the black belt final assessment, you can get a question with regard to RPN calculation. So they would have given severity rating, occurrence rating, and detection rating for a particular process, and they will ask you to calculate the RPN. So what you need to do, we need to simply multiply all the three rating scores to get the RPN value. Now, when we multiply severity rating with occurrence rating and detection rating to arrive at the RPN value, so we need to look at whether the RPN value is less than 100 or not. So if the RPN value is less than 100, then we can infer that the process step doesn't carry any significant risk. But if the RPN value is greater than 100, then we need to infer that the process step carries some significant risk, and we need to look at implementing some effective control measures, right? So if only you had already implemented some effective control measures, I told you that we will have a lesser detection rating. So the control measures are quite robust. Then the probability of occurrence of this probable cause will also be very, very remote, will be very, very less. In that case, I will automatically have a lesser occurrence rating. So this occurrence and detection rating are linked with each other, right? So if you are having a solid current control, then in that case, I will have a lesser detection rating. And when we have a solid current control, it would ensure that this probable cause doesn't occur that frequently, and we will have a lesser occurrence rating as well. So if you are going to calculate the RPN, there is every possibility that the RPN may be less than 100. So 100 is the criteria for RPN. So in case the RPN value, as I told you, is greater than 100, then we need to infer that there is some significant risk associated with that process step. And what we are supposed to do, as I told you, we need to look at implementing some effective control measures. And once we do that, we would be able to automatically reduce this detection rating. And not only that, we will also be able to reduce this occurrence rating, because by implementing some effective control measures, we would be able to ensure that this probable cause doesn't occur at all. So the probability of occurrence of this probable cause will be very, very less, and thereby we can give a lesser occurrence rating as well. So once we have the occurrence and detection rating reduced significantly, the severity rating we need to remember will not change at all. The severity rating will remain the same. The severity rating will get reduced only if you are redesigning the process step, right? So when we are coming up with some effective control measures, we will only see some reduction in the detection and the occurrence ratings, but the severity rating will remain the same. The severity rating will get reduced only if you are redesigning the process step, right? So, and then we will recalculate this RPN number. And if the RPN value is going to be less than 100, then we can feel satisfied that we have successfully mitigated the risk associated with that process step. So this is how we will perform this FME exercise. So let us look at a very simple example and a generic example and see how to conduct this exercise in a practical scenario. And please remember, this FME exercise is not an individual exercise. So it is a team exercise. So even when you are performing this FME exercise for your process steps. So we need to involve the subject matter experts associated with your process so that we will be able to come up with the right information with regard to all these, column headers that we see in this standard FMEA template, right? So let us, consider the pizza making process. So pizza making process, one of the key step or the important step is heating the pizza in the oven. So one of the important step in a pizza making process is heating the pizza in the oven. So when we heat the pizza in the oven, and this is the process step, so what can be the failure mode for this and what all ways this process step can actually fail? So the pizza can potentially get overheated or underheated. So when we heat the pizza in the oven, so what could be the failure mode? The pizza can get overheated or underheated. And what will be the failure effect because of this? So the pizza gets overheated or underheated. Obviously, the taste of the pizza will not be good. If the taste of the pizza is not good, it would result in customers' dissatisfaction. If the customer is dissatisfied, then it will have a long-term impact on the business prospects of that pizza company, right? So it would ultimately result in some serious business impact for the pizza company. So because of this, I can provide the severity rating, say 7. So I told you that if it is going to result in some, loss of business opportunities, we need to give the severity rating in the range of 7 or 8. Only if it is going to result in loss of human life, then we need to give a severity rating in the range of 9 or 10. So here maximum, it might result in loss of some business opportunities. So I'm giving a severity rating of 7. Now, what could be the probable cause as to why this, pizza can get overheated or underheated? So the probable cause for this risk could be non-maintenance of the oven. So if the oven is not maintained properly, right? If the oven is not subjected to some preventive maintenance as per the scheduled date and time, this kind of a risk can become a reality. So the probable cause could be non-maintenance of the oven. So non-maintenance of oven, how frequently this cause is likely to occur? So if it is a moderate frequency, then I will give a rating of 6 for occurrence, right? I will give a rating of 6 for occurrence. Anyway, it all depends on the current controls that we have. So current controls are not there at all for this particular risk. Then in that case, I would give a higher detection rating and a higher occurrence rating. But then there are some current controls already in place. So what are the current controls that we have in place in order to prevent this risk from becoming a reality? So the current controls are manual in nature because we are maintaining, the team is maintaining a manual logbook, the preventive maintenance team, which is supposed to provide preventive maintenance for that oven, is actually maintaining a manual logbook. So in that manual logbook, the scheduled date and time of preventive maintenance will be listed. So what are the future schedule, right, of the preventive maintenance will be clearly mentioned there. So unless and until someone in the preventive maintenance team have a look at that manual logbook, the preventive maintenance team will not even know that there is a preventive maintenance due for that oven. And there is every possibility that they may miss out providing preventive maintenance for that oven, right? So this manual control is there, but it is not quite effective. There is every possibility that people might overlook and then might not provide the preventive maintenance as per the scheduled date and time, right? That's quite possible. So we do have some control, but this is not an effective control or a robust control. So I will give a moderate rating for detection as well, say 6, right? So occurrence rating is 6, detection rating is also 6. So if the current controls are not there at all, as I told you, I would have given a higher detection rating. But then there are some control measures, but it is manual in nature, and there is every possibility that people may miss out looking into that manual logbook. So I'm giving a moderate rating for detection. And now I will calculate the RPN value, which is severity rating multiplied by the occurrence rating multiplied by the detection rate. So we get a RPN 252. So RPN greater than 100, we need to infer that the process step carries some significant risk. So 252 is a huge number for RPN. So we definitely need to infer that the process step carries some significant risk. So what we need to do, we need to look at implementing some effective control mechanism. So what I can plan to do, so I can plan to actually have some kind of an automation implemented as current control. So if I'm going to have an automated system which will keep track of the preventive maintenance schedules, then in that case, as and when the next schedule is due, this automated system will automatically trigger an email to the preventive maintenance team saying that there is a preventive maintenance due for this oven in couple of days time. So if the preventive maintenance team can actually act upon that, then it will be fine. But in case the preventive maintenance team ignores that particular email, then what will happen on the day, on the scheduled day of preventive maintenance, when the preventive maintenance has not been carried out by the preventive maintenance team, this automated system will recognize that and will trigger a complaint email to the top management of the organization. So this is like a double layered approach, right? So the first layer, the automated system will trigger a email reminding the preventive maintenance team that there is a scheduled preventive maintenance due in couple of days. But in case the preventive maintenance team fails to act upon it, then the automated system will come to know that the preventive maintenance has not been carried out on the oven and it would automatically send a complaint email to the top management complaining to them that the preventive maintenance team has missed out providing preventive maintenance for the oven, right? And the top management can very well take some action. They can immediately instruct the preventive maintenance team to attend to that oven immediately and without any delay as per the scheduled date and time. Now, through this approach, it can be ensured that the preventive maintenance is carried out as per the scheduled date and time, right? So there will not be any miss of the preventive maintenance. So carried out on the oven. So the preventive maintenance will automatically be done. So in that case, we can look at reducing this detection and occurrence ratings. So when it is a robust control mechanism, we can reduce the detection ratings. Say, I will make it 3. And we can also reduce this occurrence rating. So when we have a robust control measure in place, wherein there is no way the preventive maintenance will be missed out, then the probable cause, that is non-maintenance of oven, will not become a reality, right? So we'll be having a lesser probability of occurrence. So in that case, we can look at reducing the occurrence rating as well. So I will make this also 3 and I will recalculate the RPN because the severity rating is going to remain as 7. So as I told you, the severity rating will get reduced only if you are redesigning the process step. Just by implementing some effective control measures, so we will not see any reduction in the severity rating. And once we recalculate this RPN, we get 63 as the value, which is less than 100, and we can infer that we have successfully mitigated the risk associated with that process step. So this is how we will perform this exercise. Since I took a very simple process step just to make you understand how to perform this exercise, I could do this individually. But then all these rating scores have to be given in consultation with the team. So we cannot act individually. And also the probable cause, everything has to be identified in discussion with the team. So that will always be better. So this is a team exercise which we need to perform. So in case you have not done this exercise for your process, please do think about performing this exercise on priority because on the first day itself we saw it's always better to implement preventive action rather than allowing the damage to happen and then performing the correction and corrective action. It will be not only a costly affair, but as I told you, the implementation of correction and corrective actions will be done with lot of mental stress, which can be totally avoided. Right. So, but then if you have a scenario where couple of process steps have the same RPN value and is greater than 100, say couple of process steps have RPN as 135. So as I told you, if the RPN is going to be greater than 100, then we need to infer that the process step carries some significant risk. So couple of process steps have RPN greater than 100, then we can understand that these two process steps carry some significant risk and we need to look at mitigating the same. So when they have the same RPN, which one you would prioritize implementation of control measure? So we need to look at the severity rating of these process steps. So whichever process step has a higher severity rating, that process step would be prioritized for implementation of the mitigation action or the effective control measure. So there can be a question on this in the black belt final assessment. So that is why I've given you this information. So if the RPN is going to be greater than 100 and is same for a couple of process steps, then we will prioritize implementation of control measures based on highest severity, right? So they had given the scenario that couple of process steps have the same RPN and is also greater than 100. So how will you prioritize implementation of effective control measure? So this will be the question asked. So you need to pick the option based on severity. So whichever process step has a higher severity rating, that process step will be prioritized for implementation of effective control measure, right? So this is about the FMEA exercise. And then, as I told you yesterday, so we'll be looking at yet another tool under improved phase, which is design of experiments. So this is a black belt specific content. So we'll be looking at this on the final day, on the 12th day of this training session.
Can I
As far
have a
as,
question? Sorry, sir.
yeah, tell me.
About the occurrence.
Yeah.
So the occurrence is of the probable causes, not the failure, the occurrence of the failure of the process.
No, no, no. Well, the probable causes are going to trigger this failure both, right?
What if there are more than one
Yeah,
probable
yeah.
cause?
We need to have a separate occurrence rating for each and every probable cause. So it can happen. So a
Hmm.
particular risk can have multiple probable causes, which can actually
Yeah.
trigger, right? So in that case, we will have the occurrence, provided in different rows.
Okay.
Sridhar, do you have a sample sheet where it says that this is the process step, this could be the failure mode, then severity, then cause? If that would help to understand
No, no,
better.
no. The process that I have actually dealt with may
Mm-hmm.
not be the one which you are currently working on, right? So I have predominantly done this exercise for F&A processes. So that's why I took the example of pizza making process, which all of you would be able to understand,
Okay.
right? But then, see, as I told you, when you actually work on a project, or even when you actually work on this exercise as a silo one, so in case you are stuck up with, identifying the probable cause or the failure mode for a particular process step, you can always discuss later, right? That's not going to be a problem. But then if I have the sheet, I have the exercise done, so I can provide you with an example. In fact, if you can Google search, you'll get plenty of examples for FME. That's not a big deal at all, right? But how are you going to relate it to your own process? That's going to be the challenge. So for that, we can follow this step, but then if you find it challenging, if you're not able to actually make a start, so you can always discuss. I can understand about your process, and then I can suggest, how this can be done,
Right.
right? Otherwise, I can send you the kind of FMEA example that I have, so I can send it separately to the common WhatsApp.
Yeah.
Okay. Fine. So this is about the contents that we have in the under the improve phase pertaining to the common GB and BB curriculum. So we'll now step into the final phase in the DMAC approach, which is the control phase. So as I told you, we're yet to see this design of experiment, so which will be a black belt specific curriculum. So we are even going to work out an exercise under design of experiment, right, on the 12th day of this training session. Fine. So now we will step into the final phase in the DMAC approach, which is the control phase. So what do we do in control phase? So at the end of the improve phase, as we can understand, the project team would have actually improved the process performance, would have even achieved the project goal, would have actually scaled up the solutions covering the entire process, would have trained the associates with regard to the improved process steps, and would have also obtained their buy-in that they would follow the new process in the future. So with all these things done, the project team would actually hand over the improved process to the process team. Now the process team needs to monitor whether the improvement is sustained over a period of time. There are two things that the project team is supposed to do in order to ensure sustenance of improvement that the project team has been able to achieve at the end of the improve phase, right? Number one, as I told you at the beginning, they need to look at the sources contributing to the process variation and should have attacked the same, right, as part of the Six Sigma project initiative. So once we have attacked the sources contributing to the process variation, we would be able to make the process performance much more consistent, right? So when we have made the process performance much more consistent, we can be rest assured that the improved performance will be sustained over a period of time. And the second part, as we discussed, we need to get the buy-in from the associates who are part of this process because they are the ones who are supposed to execute the process as per the improved process steps, right? So if they revert back to the old methodology, then we may not see the sustenance in the improvement made, right? So it's important that we get the buy-in from the associates who are part of that process and they start implementing or executing the process as per the new methodology. Then we can see sustenance in the improvement made. But then how to monitor this sustenance in the improvement made at the end of the improve phase? So we need to use a tool called control chart. So control chart is the tool which we will use for monitoring the sustenance of the improvement made at the end of the improve phase. And the quality expert who actually invented this control chart is Walter Schubert. So we kind of discussed about Walter Shewart on the first day of this training session. So if you would remember, he's the one who actually invented this control charts when he was working in US Army. And he was the one who was approached by the US government to actually travel to Japan to help them resurrect their economy after the Second World War. But then Walter Shewart did not go to Japan, and the offer was made to his deputy, Edward Deming, who traveled to Japan, and rest is history. But then Walter Shewart is the one who actually invented control charts, and hence all these control charts are referred as Shewart charts. All these control charts are referred as Shewart charts. So what do we actually try to achieve by monitoring the process performance through control chart? So we would try to identify if the process is influenced by any assignable or special cause variation. So what do we do when we monitor the control chart? So we will be trying to identify if the process is influenced by any special or assignable cause variation, right? So as I told you, the process ideally should be influenced only by the common cause variation. The process should be ideally influenced by the common cause variation. So as part of the control chart exercise, we'll be looking at whether the process is influenced by any assignable or special cause variation, right? So if they are asking you what is the primary objective of using a control chart, so we need to pick the option that the control chart is used for identifying the presence of any special or assignable cause variation acting on the process, right? So when we are actually formulating the hypothesis statement for a control chart scenario, so what will be the null hypothesis? So the null hypothesis for a control chart scenario will always be the process is influenced by common cause variation. So what will be the alternate hypothesis which we need to establish by looking at the control chart, that the process is influenced by some special or assignable cause variation, which would be an exceptional scenario, right? So whichever is the exceptional scenario will be part of your alternate hypothesis. Whichever is your normal scenario or the ideal scenario will be part of your null hypothesis, right? So each and everything you can come up with the hypothesis statements. So for control chart, the hypothesis statement will always be like this. The null hypothesis will be the process is influenced by common cause variation alone. And the alternate hypothesis will be the process is influenced by assignable or special cause variation. So when we monitor a control chart, the primary objective is to identify the presence of special or assignable cause variation acting on the process. So there can be a question on this. So let me just make this in bold font. So they would have asked you, what is the purpose of monitoring a control chart? So we need to pick the option. So the objective is to identify the presence of assignable or special cause variation acting on the process, right? So as I told you, the process should be ideally influenced by common cause variation alone. So this would mean that the process performance is also consistent. So only when the process is influenced by common cause variation alone, so our process performance will also be consistent, right? So when the process is influenced by common cause variation alone, we can also say that the process is under statistical process control, SPC. So when can you say that the process is under statistical process control? Only when the process is influenced by the common cause variation alone, or in other words, there is nil presence of assignable cause variation acting on the process, right? So how this control chart will actually look like? So let us see how this control chart will actually look like. So this is a graphical format, as we all know. And in fact, control chart is the sophisticated format of a run chart. So you've already seen how a run chart will actually look like. So run chart will have an average line at the center, right? And we will plot the data points pertaining to the CTQ metric, right? And we can find out whether the data distribution is random or non-random by looking at the run chart. Again, when we discussed about the run chart concept, so I told this very clearly. So only when the process is influenced by common cause variation alone, the data distribution will be random and the process performance will also be stable, right, and consistent. But on the other hand, if the process is influenced by any of the four non-random characteristics, then the data distribution will be non-random and we can infer that the process is influenced by some special or assignable cause variation. And the process performance will also be not consistent. So in case of control chart, since this will be a sophisticated format of a run chart, so again, control chart or run chart, we'll be plotting the data over a period of time. So that means we will have the time zone along the x-axis. So in case of a control chart, so we will not only have the average line at the center, we will also have couple of lines apart from the average line, one at the top called upper control limit and one at the bottom called lower control limit. So here we have control limits along with the average line. So at the top, we will have the upper control limit, which is referred as UCL. And at the bottom, we have the lower control limit, which is referred as LCL. And one thing we need to clearly remember here is these control limits are totally different from specification limits. So people always would tend to get confused between the control limits and the specification limits. So control limits are totally different from the specification limits. So control specification limits, we all know. Who provides the specification limits? The customer provides the specification limits, whereas the control limits are derived through the process performance. So how will you arrive at this UCL? So UCL can be calculated by using this formula, average plus 3 times the standard deviation, and LCL will be average minus 3 times the standard deviation. So 3 into standard deviation is what we would consider for constructing the UCL and LCL lines in this control chart, right? Because we already seen 3 into standard deviation or the 3 sigma limits would cover 99.73 percentage of the data points in a normal distribution, right? And this 99.73 percentage is approximated to 100%. So UCL, it will be at a distance of 3 into standard deviation, or we can say 3 sigma distance from the average line. And LCL will be minus 3 sigma, right? So it will be the other way around. So minus 3 into standard deviation. So it will be separated by distance of 3 standard deviations on either side. Average will be separated by distance of 3 standard deviations on either side. On the upper side, we will have the upper control limit. The bottom one, we will have the lower control limit, right? So when we have a control chart depicting like this, then how to identify the presence of assignable or special cause variation acting on the process? So we have something like 8 rules which can be applied in order to identify the presence of assignable or special cause variation acting on the process. And out of these 8 rules, 4 rules we have already seen as part of the run chart concept. So the 4 rules we have already seen as part of the run chart concept. So those 4 rules will be the first 4 and the next 4 will be slightly stricter, right? So unless and until you construct the control chart using Minitab, it would be very difficult for us to apply the next set of 4 rules that we have in this list. So it will be very, very, very difficult, as you yourself will be able to find out in a short while. So let us look at all these 8 rules. The first 4, as I told you, the ones which we have already seen as part of the run chart concept. So the first rule is one data point getting plotted outside the control limit. So if you have a data point pertaining to the CTQ metric getting plotted outside the control limit like this, then we need to straight away suspect the presence of assignable or special cause variation acting on the process. right? So even if there is a single data point getting plotted outside the control limit, we need to suspect presence of assignable or special cost variation acting on the process. And what is the second rule? Second rule, if you have 6 consecutive data points showing an upward or downward trend, then also we need to infer that there is some presence of assignable cost variation acting on the process. And these data points could very well be within the control limits. But then if you find 6 consecutive data points showing an upward or downward trend, then also we need to suspect presence of assignable or special cost variation acting on the process. Or if you have 8 consecutive data points clustered on one side of the average line, then also we need to suspect presence of assignable or special cost variation acting on the process. And then if you have 14 consecutive data points alternating up and down the average line, then we need to suspect presence of assignable cost variation acting on the process, right? So the first one is what we would call as a mixture, where we have two extreme data points being plotted, right? So the data points getting plotted at two extreme ends in a control chart. So that is what we would call as a mixture. And then the second one is nothing but the non-randomness due to trend, right? 6 consecutive data points showing an upward or downward trend. And the third one is the non-randomness due to clustering, wherein we will have 8 consecutive data points clustered on one side of the average line. And then the fourth one, when we have 14 consecutive data points alternating up and down the average line, we will call that as oscillation. So these are the 4 scenarios that we can actually look at and infer the presence of assignable or special cost variation acting on the process, right? But as I told you, the next set of 4 rules are going to be slightly stricter. So the fifth rule is 2 out of 3 consecutive data points which are more than 2 sigma from the center line in the same direction. So as I told you, the control limits are fixed at 3 sigma limits. So just below 3 sigma, we will have the 2 sigma line. So it will be very difficult for us to visually observe this. So that's why I told you. The next set of 4 rules can be applied only if you are going to construct the control chart using Minitab. And then down below that will be the 1 sigma line. So this will be minus 1 sigma. So 2 sigma to minus 2 sigma, 1 sigma to minus 1 sigma. So if you have 2 out of 3 consecutive data points getting plotted outside this 2 sigma limit band. So outside this plus 2 sigma to minus 2 sigma. So from the center line, the same direction, then also we need to suspect presence of assignable or special cost variation acting on the process. Or if you find 4 out of 5 consecutive data points, which are more than 1 sigma. So if you find 4 out of 5 consecutive data points getting plotted outside this 1 to minus 1 sigma band, then also we need to suspect presence of assignable or special cost variation acting on the process. Or if you find 15 consecutive data points which are within 1 sigma from the center line. So within this 1 sigma band, that is between plus 1 sigma and minus 1 sigma, if you are able to find 15 consecutive data points getting plotted in that particular band, then also we need to suspect presence of assignable cost variation. And finally, if you observe 8 consecutive data points which are within 2 sigma from the center line. So if you are observing 8 consecutive data points between plus 2 sigma and minus 2 sigma, then also we need to suspect presence of assignable cost variation acting on the process, right? So these are the 8 rules that we would apply for identifying the presence of assignable or special cost variation acting on the process. And all these 8 rules will be applicable only for continuous data control chart. So we have control charts for both continuous data as well as for the discrete data. So all these 8 rules will be applicable only for continuous data control charts. But then if you are constructing a discrete data control chart, we will have only the first 4 rules applicable for the same, right? So for a discrete data control chart, only the first 4 rules will be applicable. And in fact, the first 4 rules we can visually observe and then find out if the process is influenced by any special or assignable cost variation, right? So these are the 8 rules that we would apply for identifying the presence of special or assignable cost variation acting on the process. So let us look at the list of control charts that we have for both continuous data as well as for the discrete data. So one thing we need to remember, continuous data is also called as variable data, right? Just like how discrete data will also be known as attribute data, continuous data will also be referred as variable data. In fact, there can be a question on this. The variable control charts will contain plotting of continuous data points, right? So that is the option we need to pick because the other name for continuous is variable, right? So that is what I have written here. So continuous data control charts will also be referred as variable data control charts. So under that, we have 3 control charts which can be used for different scenarios. One is the IMR chart. IMR, the full form is individual moving range chart. And this individual moving range chart can be applied only if you have a lesser production rate. So that means you have the production rate, say, a project getting closed, say, once in 15 days or once in a month. So we don't have lots of data points to plot in a control chart. Then we will be using IMR chart, which is individual moving range chart. But then if the production rate is slightly high, you can always form a subgroup of sample data points. In that case, I will use the control charts applicable for subgroups like X bar R chart and X bar S chart. So X bar R chart is nothing but X bar range chart. So X bar R chart is X bar range chart. And we all know range as a measure of variation can be applied only if the sample size is 6 or less than 6, right? Whereas if the sample size, the subgroup sample size is going to be greater than 6, then we need to use X bar standard deviation chart, right? So how this sample subgroup will actually look like? Say, for example, you are collecting the data every 1 hour, right? Because as I told you, control chart, we will be plotting the data over a period of time. Suppose you are collecting the sample data points every 1 hour. So 10 a.m. we will have, say, let us say 4 sample data points, 11 a.m. 4 sample data points, and then 12 noon again 4 sample data points. Like that it is continue, right, for some 30 hours. So when we have 4 sample data points collected on an hourly basis, so we will say that the subgroup sample size is 4 for this scenario. The subgroup sample size is 4 for this scenario. So for this, we can construct X bar R chart. But then if you have a subgroup sample size greater than 6, then we need to use X bar standard deviation chart. So in this X bar R chart, we will calculate the X bar values for all these subgroups, and we will also calculate the range values for all these subgroups. And then we will have a control chart wherein we would plot the X bar values alone, and we will have another control chart wherein we will plot the range values. So in case of continuous data control charts, we will have a control chart for the measure of central tendency, and we will have another control chart for plotting the measure of variation, right? So two control charts will be displayed when we construct X bar R chart, right? So these are the 3 control charts that we have for continuous data, which is also referred as variable data. Similarly, we have control charts for discrete data, right? So under discrete data, we have control charts for binary discrete data, which is nothing but defectives type of data. So in the final assessment, you will not get questions pertaining to the control chart exercises. So especially in Greenbelt final assessment, you will not get questions pertaining to the control chart exercises, right? But you will get a question wherein you would be asked to identify the appropriate control chart for a given scenario, right? The scenario will be given as a question and you'll be asked to identify the appropriate control chart. So you need to look at which metric or which data you need to plot in the control chart. If it is going to be defectives data, then we need to find out whether the sample size is varying or the sample size is constant. So if the sample size is constant, or if they had mentioned in the case scenario that the sample size is in a standard format, then we need to apply NP chart for that scenario. Or if the sample size is varying, or if they had mentioned in the case scenario that the sample size is a percentage value of the overall production, then in that case, we need to apply P chart for that scenario. So what is this constant sample size and varying sample size? So in case of discrete data control charts, we will have sample size in one column and the discrete metric in the other column. So it could be defectives or defect. So if it is defectives, we need to understand it would represent binary discrete data. If it is defect, we need to understand it would represent count discrete data. So if you have a constant sample size, say we are actually plotting this data on a daily basis, and suppose the sample size is going to be 100 on each and every day, and you have the count of defectives, right? So if you want to plot for this scenario, you'll be using NP chart. But then if you have a varying sample size, one day it is 100, next day it is 120, third day it is 75 and all, then we'll be using P chart, right? So both NP chart and P chart, we would be plotting the defectives data, but then NP chart to be used if the sample size is constant and P chart to be used if the sample size is varying. But then the case scenario that will be given in the question, so you will be it would be mentioned that the sample size is in a standard format for constant sample size. So they wouldn't have mentioned it as a constant sample size. They would have mentioned it as the sample size is in a standard format. So we need to understand that they're referring to a constant sample size. But then for varying sample size, they wouldn't have mentioned that the sample size is varying. They would have mentioned it as the sample size is a percentage value of the overall production. So when they have mentioned that the sample size is a percentage value of the overall production, we need to understand they are referring to the varying sample size, right? So in that case, we'll be using P chart for that scenario. So multiple control charts will be there as multiple options. So we need to pick the relevant control chart from that multiple choice, right? So this is the kind of questions that will be asked in the green belt final assessment. So in the black belt final assessment, you'll be asked questions pertaining to control limits calculation. So I will, show you how to perform the calculation, right, on the final day of this training session. In fact, I have also provided you with the template, which can be used for calculating the control limits for the various control charts, right? So for the Greenwell final assessment, as I told you, so you will be asked to identify the appropriate control chart for a given scenario. And this is how we need to do. First, look at whether we are supposed to plot the defectives data or the defect data. So if you are supposed to plot the defectives data, and if the sample size is in a standard format, then we need to understand that they are referring to a constant sample size. We need to choose NP chart from the list. Or if they had mentioned that the sample size is a percentage value of the overall production, then we need to infer that they are referring to a varying sample size. In that case, we need to pick P chart as the option. The same way for count discrete data, which will be defects type of data, we have C chart for constant sample size, or if the sample size is in a standard format. So instead of defectives, we will have the defect count for plotting in these count discrete data control charts, right? So C chart for constant sample size, or if the sample size is in a standard format, and U chart for varying sample size, or if the sample size is a percentage value of the overall production. Clear? So if you find that you need to plot defects type of data, but then they had given the sample size is in a standard format, then we need to infer that they are referring to the sample size as constant, and we need to pick C chart as the right option. But then for the same defects data to be plotted in the control chart, if they had mentioned that the sample size is a percentage value of the overall production, then we need to understand that they are referring to a varying sample size. In that case, we need to pick U chart as the correct option. Clear? So this is how the case scenarios will be provided as questions in the GB final assessment, and you'll be asked to identify the appropriate control chart that you can use for that case scenario, right? So this is what we have for the common green belt and the black belt curriculum. So as I told you, the 11th and 12th day will be looking at the black belt specific curriculum, and anyway, so even the black belt final assessment, so you will get questions pertaining to the common curriculum, right? Whatever we have seen so far in these 10 days of training session. So you can get questions in the black belt final assessment as well. Apart from that, as I told you, you will also get some questions pertaining to the black belt specific curriculum, right? So with this, we actually come to the end of the common green belt and black belt curriculum. So as part of the black belt curriculum, as I told you, so we will be looking at the exercises under testing of hypothesis. We will be looking at exercises under correlation and regression analysis on the 11th day. And on the final day, we'll be looking at a concept called design of experiments under improve phase, and we'll be working out an exercise under design of experiments. And then we will wind up this training session by working out some 3 exercises under control chart. So we'll be constructing an X bar R chart and P chart and also U chart, right? So these are the 3 control charts that we will be constructing on the final day of this training session. And with that, we will be winding up the training session, right? So as part of the control charts creation, we will also see how to calculate the control limits, the upper control limit and the lower control limit for all these 3 control charts, X bar, R chart, and then the P chart, and then the U chart. As I told you, I've already given the template. So you just need to input the values and get the answer. So control limit calculations will be asked as part of the black belt final assessment. So any doubt, any questions? So I will send the FMEA exercise example through the common WhatsApp group. Any question, any observation, any suggestion? Everything is fine? Yes or no?
Yes.
So even if you are not able to respond orally, just type it in the chat box.
Yeah, Sridhar, fine.
Good.
Is the
Please,
assessment
please respond, right? Please, whenever I ask questions, it's please respond. Otherwise, it will be so much demotivating for the trainer. I hope you all can understand my plight, right? So please do respond, because otherwise become too monotonous, right? I'm doing all the talking, which is fine, which I'm supposed to do. But then when I ask some question, right, please do respond. Then only I can, move on further. Yes, please. Someone was asking question about the assessment.
Yeah, the assessment is similar to the mock exam, like
Yeah,
20
yeah, yeah.
questions.
It will be similar to mock exam. Only thing is you would need to answer 50 objective questions or multiple choice questions in 60 minutes. Mock exam, you had to answer 20 questions in 30 minutes, right? So
Yeah,
this will be slightly much more stringent in the sense you need to answer 50 multiple choice questions in 60 minutes.
I see. Okay.
So the 60 minutes, the time will start from the moment you actually, click on that link and start answering.
Yes, okay.
Any other question? Yeah, fine. So let us look at the project exercise. So let me just show you a couple of PPT presentations. Fine. As I told you on the first day, uh, let me take you through the sample project document. So this sample project document will be sent to you through email. So once you fill in that project initiation form and submit it to me after the training sessions are over. In fact, I'll be sending you the link for accessing that project initiation form only after the final day sessions, right? So that you can focus on the assessment part as of now. Then you can access that uh, link for filling in the project initiation form. And once you send it to me, I will be sharing this, sample project document. But then for now, let me just take you through the sample project document. So this is a, a Greenbelt project which was carried out in F&A process, finance and accounts process. It says improvement in spot percentage. The spot, the full form is supplier paid on time, right? Spot percentage, the full form is supplier paid on time percentage. So each supplier needs to be paid within a certain time frame. So that is what we would call as net 30 days or net 45 days or net 60 days. So if you have entered into an agreement with the supplier that you'll make the payment within, say, 30 days, then that supplier will be net 30 supplier. Or if you have agreed that you'll make the payment within 60 days, that supplier will be net 60 supplier, right? So you would have actually agreed to make the payment to a particular supplier within a specific time frame. And if you fail to do that, you are liable to pay penalty to the supplier. So the spot percentage will be calculated based on the number of invoices you are able to settle to a supplier within that agreed timeline, right? So the spot percentage is very low, then we can very well understand that it might have some serious financial implications for the service provider organization, right? So the company name and other important and confidential information have been completely masked in this particular document. So it would only talk about some important features that were carried out as part of the project exercise. So the project charter, whatever we discussed, you would find all those elements as part of this slide. And then we created the SIPOC for this spot percentage process, right? And then we also, performed a CTQ drill down. So CTQ drill down, we actually looked at it from two different angles. So one is the spot percentage, right, pertaining to the various sub-processes within the process. And the other one is the time taken to execute each and every process that we have in our time to execute or time taken to execute each and every activity. I should not say process. So it's each and every activity within that invoice processing activity. Because when the time is going to be somewhat higher for a particular activity, then we can understand that the overall time will be missed for making the payment to the supplier, right? So the time taken for the multiple activities that we would practice in that invoice processing process has also been kind of tracked as part of the CTQ drill down, right? So this is just a design as to how we need to perform the CTQ drill down. And then we also come up with the as-is process map in order to identify the lean opportunities existing in the process. And these are the lean improvements that were carried out. And then under measurement, right, under measure phase, the measurements, right, would indicate all the important matrices that we will use as part of this project exercise. And I've also provided you with the operational definition for all these key matrices so that all the stakeholders will be on the same page with regard to how a particular metric will get measured. And then we have the data collection plan. So how the data is going to be collected. And we did the measurement system analysis, even though the data was collated in the form of a report, right, pulled out from a workflow tool. But then we still went ahead and performed the measurement system analysis just to ensure that whatever base data we are getting from that report is absolutely valid. And then we calculated the baseline process capability. So the sigma level at a sub-process level is also calculated here. And the overall sigma level for the baseline performance stands at 1.88. So as we can see, the spot percentage is hovering around, say, some 52 to 55%. That's it. It's very, very low. And then we did a Pareto analysis just to identify the major sub-processes which are actually contributing to the low spot. And then the company codes contributing to the low spot. Then the trend analysis at company code level was performed. So we could identify which particular company code, had a lesser sigma level, right, or the lowest sigma level. And those company codes can be identified as the problem areas within the process. And we also did a turnaround time analysis, right? As I told you, the time taken to perform each and every activity will have a direct bearing on the overall time taken to make payment to the supplier. So the company code wise, turnaround time details is what is given here. And we could identify certain queues which were actually taking a longer time for processing. And those have been identified for some multiple company codes. And then, we also calculated how much time each activity would take, right? This is kind of a CTQ drill down. How much time each activity would take to process. And we could always identify the problem areas through this. And then we came up with the cause and effect diagram for this low spot percentage, right? And we could identify something like 8 causes. And since the number of causes were very few, so we were able to perform hypothesis testing for all these 8 causes. So we validated with the help of data whether these causes are actually having a huge impact on the business problem. So whichever cause had a star, right, in that hypothesis testing slide, so we need to understand that that cause is a relevant cause for the business problem. So as we can see, supplier sending the invoices after 5 working days from the document date is indeed a relevant cause for the business problem, because after performing the hypothesis test, we could understand that there is some statistical difference, right? So we have indicated this by the star sign. So this is also another, solid reason as to why the spot percentage is low. So whichever hypothesis test doesn't contain a star, we can understand that those are irrelevant causes or less impactful causes. So out of 8 causes identified, 5 proved to be very, very significant, right? So for these 5, vital causes, we have to come up with the solution. So the solutions were proposed, right? And then the implementation strategy was also kind of finalized for implementing these solutions. And then once the solutions were implemented, attacking all these, 5 causes, so we again performed the hypothesis testing in order to validate whether the solution implemented is effective or not. So this is a comprehensive exercise that we carried out, right? We once again performed hypothesis testing just to validate whether the solution implemented is quite effective or not, right? So we could find that the solutions implemented for all these 5 causes were quite effective. And we also performed the hypothesis testing for the improvement in the overall spot percentage. And we could find that the overall spot percentage also showed some significant improvement, right? And then we looked at the trend chart, right, wherein we kind of calculated the improved process capability. So this is the kind of improvement we could witness in the problematic sub-process areas. And this is the overall improvement that we could see. So there is a significant jump in the spot percentage in the post-improvement scenario. The pre-improvement scenario, it was around this range. The post-improvement scenario, it has gone up to something around 80%. From 55% is a jump to 80%. And this is the improvement we could see in the sigma level. So the earlier baseline sigma level was 1.88. Now it has become 2.30. And the control measures to ensure that the improvement or the solutions implemented kind of are sustained, right? So what are the control measures that we need to have in place? So instead of constructing a proper control chart, we just went ahead and constructed a trend chart. So even this trend chart, the performance is supposed to be consistent, but one of the week, we suddenly had a dip and we could find out what is the assignable cost here. And we were also able to perform some corrective action to eliminate that assignable cost. So this is the sample project document. So this will just give you an idea as to how we can execute a Six Sigma project and what are all the tools that we can apply. So the spot percentage we need to understand is a binary discrete metric, right? Spot percentage is a binary discrete metric because when you take an invoice, the invoice can either be paid within the agreed timeline to the supplier, or the invoice will get paid exceeding that agreed timeline to the supplier, right? So only these two options can take place as a result. So that's why the spot percentage will be considered as binary discrete metric, right? So whatever tools we can apply for this binary discrete metric, we have applied as part of the project exercise. And this is the project documentation template, right, that we are seeing here. So this would actually help you to document your project findings. So the headers will definitely provide you with necessary hint as to how you can proceed with the Six Sigma project exercise. But as I told you, in case you need my support, you can always connect with me after the training sessions are over. So I'm willing to go out of the way and help you guys out. Right? So this is as far as the sample project document and the project documentation template, which you can use for documenting your Six Sigma project. Right? So it can be a real-time project or it can be a simulation project. So let me show you the project initiation form. So this is the project initiation form. So this is actually a Google form. So that's why I told you, I will just send you the link to access this form after the final day sessions are over. So those who are interested to work on a Six Sigma project, as I told you on the very first day, it's not a mandatory exercise. So once you clear the green belt and the black belt final assessments, you will anyway get the green belt and the black belt certifications. But this project completion is an additional effort, and IMC would be rewarding you for this additional effort by issuing a project completion certificate, right? So this is not a mandatory exercise. This is an optional exercise. So only those who are interested to work on this Six Sigma project can actually fill in this project initiation form. So the link for which I will be sending after the final day sessions are over. So this is a very simple form which should not take more than 5 minutes for you to fill in. So you need to update your email and also your full name and your WhatsApp number and your current work location and the training batch number. So this training batch number is 557. And then we need to choose the project that you have actually opted. So we have given the list of projects which you can actually choose from. But then if the one that you are planning to execute is not there in this list, we can also choose other and then provide the project name. Suppose the project title which you plan to work is not there part of this list, we can choose other and then provide the project name, right? So once you fill in this project initiation form, as I told you, we can also work on a simulation project. Simulation project means you can just imagine the problem area within your process and you can cook up some data around that problem area and arrive at the baseline performance of that CTQ metric, and we can come up with the solutions, right? Or we can come up with the causes and then the solutions, and we can also cook up some data to show the improved performance and then close the project, right? So that is what we will do in a simulation project exercise. So it should not take much time, but that itself will be providing you with some good experience as to how you can implement all these learn tools and techniques, right? So once you complete the project document, right? So whether it's a real-time project or a simulation project, so once you complete the project document, you can send it to me. So I'll be, sending my email, which you can actually send the project document. So I will review it. In case of any modifications required, I would suggest what are all the modifications that you are supposed to perform. And once the final document is ready, I will just forward it to the IMC certification team and they will take care of the certification procedure. Clear? So for filling in this, project initiation form, you'll be given 2 days time. As I told you, it will not take more than 5 minutes, but still, right, accessing it and then filling in this form. So I'll give you 2 days time. So if our training sessions are getting over day after tomorrow, right? So it's on Thursday, 22nd. So you'll be given time till 24th evening to submit this filled in project initiation form, right? So 22nd, our training sessions are going to get over. So immediately after the final day's training sessions, I'll be sending you the link to access this project initiation form. So once you fill in, you need to send this project initiation form before 24th of January, before EOD, end of the day, 24th January 2026, right? So any request that I receive after 24th will not be entertained. So let me make this point very clear. So if you're interested to work on the project exercise, please ensure that you fill in this project initiation form and send it to me on or before 24th of January 2026, right? On 25th of January 2026, I will collate the email IDs of the participants who have actually opted to work on this project exercise. And then I will send you the sample project document and also the project documentation template, which you just now saw. And apart from that, I will also let you know how to submit the project document. So in what format you need to submit the project document and how much time will be given to you for submitting the project document. Clear? Any doubt?
Sir, I have a question.
Yeah,
In the project list you have mentioned, right?
yeah,
Improve quality,
yeah,
and reduce risk defect. I work
yeah.
in insurance and I actually take care of quality of claims. and
Okay.
underwriting both, right?
Okay. Okay.
Can I take this improve quality?
Yeah. Can do that.
Yeah. So just wanted to
Yeah. Can very well do that.
understand that. Right.
So whichever, topic will be relevant to your process, you can choose from this list. But in case you don't find that topic here, you can also choose other and then provide that header name.
Understood. Thank you.
Yeah.
And Sridhar, if there's a company policy not to expose the data outside the company.
Yeah, you cannot do that. No, please don't take that risk. So if your company is against, providing or exposing the data to some external source, please don't, provide the data to us. Please don't submit the project document with that data. So it will be
Mhm.
risky for you, right? So that's why I told you, even the simulation
Yeah.
project will be accepted. So you don't have to
So
really.
how to go about the simulation project? I mean,
No,
not.
simulation project, you can just imagine a problem area at your workplace. So you can just, if quality is an issue, so you can think about improving quality, or timely delivery is an issue. You can think about improving the timely delivery.
Okay,
Then we
okay.
can cook up the data and come up with the baseline performance. So I will help you. As I told you,
Okay.
I will guide you as to how we can execute the project. But as I told you on the first day, I may not be able to guide you on a day-to-day basis. But at least once in a week or once in 10 days, we can always connect.
Yeah, that works. Because I checked with my current manager that the data cannot be exposed outside the
Yeah.
company.
No. That's absolutely fine.
So,
We also understand that. That's why, we are also flexible, right? So we are saying that even simulation project is, because unless and until you submit that project document, you'll not be able to review it and will not be able to kind of issue the project completion certificate as well.
right.
So obviously, only if
And
the
they'll pick
management is
something.
agreeing
Yeah.
to, only if the management is agreeing to share the data with us, then you'll be able to do so. Otherwise, you need to work on the simulation. The
Right.
problem can be the same, but you can actually cook up the data and then provide us the project document.
Okay.
For the project, it doesn't need to be a problem now. Yes?
Yeah, correct. Yeah,
Okay.
that's what I told you. So you can also imagine a problem and then.
Yeah. Okay.
Because some of the organizations, they may not allow you to work on a Six Sigma project. That may not be their priority as well, right? Or as Kulvinder pointed out, right? They may not agree to kind of share the data with an external source.
No,
Right?
what I meant is if I choose, for example, sales, improve sales, or reduction of energy, after doing all the exercise, maybe the result is little improvement. Is that okay?
No, that's what. We need to fix the project goal, right? So at the beginning of the project exercise. And that project goal should be an aggressive, should not be something that you can easily achieve. So these are the things that I will review, right? So when you submit the project document to me, so I will review whether you have actually fixed the project goal appropriately, whether the breakthrough improvement has been achieved, even though it could be an imaginary improvement, as I told you. So all those modifications need to be carried out. Yes. I will see some of the critical, activities that are supposed to be carried out as part of the Six Sigma project have been done or not, have been carried out or not. You may not physically carry out when you are working on a simulation project, but at least we need to show all those things in the slide so that you will be able to understand that these are the things that I'm supposed to do when I actually work on a real-time project. See, all these things should give you some new learning, right? So this theoretical learning is one part, but this simulation project exercise, even though it's not a real-time project and a simulation project, this will actually give you that practical learning, which would definitely help you when you actually work on a real-time project later on, which anyway you will do as a Six Sigma professional. So any other question?
Sir, what is the timeline for the submitting the project?
3 months.
3 months. Okay, sir.
3 months. So if you're working on a simulation project, it can be completed even within a month,
Okay, okay, sir.
right? Okay. Okay then. So no more questions. Then we will have a break now. So we'll come back and then we will do a quick revision of the statistical exercises, right? So that will be after a 15-minute break. Hello, friends. I'm back. Hope you're all back as well. So let us quickly look at the concepts that we covered these 10 days of training. So define phase, we started with understanding the types of customer. So before that, who is a customer? So customer types are external customer and the internal customer. And then we looked at the different sources for gathering the customer requirement. And then we prioritize the customer requirement through a model called Kano model. Then we will identify the CTQ metric for the business problem. Then we'll perform the CTQ drill down in order to identify the problem areas within the process which requires improvement. Then we will prepare the introductory document for any Six Sigma project called Project Charter. And then we will create a macro level or a high level process flow called SIPOC. And then we will also work on a micro level as is process flow in order to identify the lean opportunities existing in the process. So affinity diagram is the tool which will be used extensively as part of the define phase. Then under measure phase, we looked at the basic data concepts and then the data collection plan, then the types of data, discrete data and continuous data. Under discrete, we have binary discrete data. And then we looked at the descriptive statistics measures, measures of central tendency, mean, median, and mode. So mean is an arithmetical or arithmetic average, which needs to be applied only if the data set doesn't contain any outlier. So if the data set has any outlier, then we need to use median. And then measures of variation, range variance, and standard deviation. Then we looked at the graphical representation of data, histogram, graphical format for continuous data, bar chart, graphical format for discrete data, and then pie chart, which is the graphical format or pictorial format to represent proportions, and then run chart. So line chart is the graphical format to depict the performance over a period of time, and run chart, which is a sophisticated format of line chart, will be used for validating whether the data distribution is random or non-random. And then finally, we looked at box whisker plot, which is the tool for identifying the outliers existing in a data set. Then we looked at the measurement system, or before that, the concept of yield. We understood how to calculate the roll throughput yield given the throughput yield values. And then we looked at measurement system analysis, both for discrete data as well as for continuous data. So this is to validate the correctness of the base data that we would be considering for calculating the CTQ metric. And then we looked at the probability distribution. So under discrete, it was binomial distribution and Poisson distribution. So binary discrete data would follow binomial distribution and the primary metric is proportion. Count discrete data would follow Poisson distribution and the primary metric is average. Then we looked at the most famous continuous data distribution, which is normal distribution. So under that, we understood the property of a standard normal distribution. And also we looked at the area coverage within various sigma limits for a normal distribution. So within 1 sigma limit, 68.27%, within 2 sigma limits, 95.45%, and within 3 sigma limits, 99.73%. And then we looked at the calculation of sigma level for a continuous data scenario, which is normal. And then we also derived the relationship between the long-term and short-term sigma level as per Motorola. And then we looked at normality test. So Anderson-Darling test is the one which we would perform to validate the normality of a data distribution. And we also looked at the steps to convert a non-normal data set into a normal data set. And then the final chapter in the measure phase, process capability analysis. So for discrete data, we understood the difference between a defect and a defective. And we also got introduced to a new term called opportunities for error. And then we looked at the various process capability matrices that we have for both discrete or for both defect and defectives type of data. So for defects, it will be DPU, DPO, which is defects per opportunity, DPMO, defects per million opportunities, and then sigma level. And for defectives data, it will be defectives per unit, defectives per opportunity. Both will be same because opportunity will be considered as one when we calculate from a defectives perspective. And then the equivalent metric for DPMO will be ppm, parts per million, and then we'll calculate the sigma level. And then we looked at the continuous data process capability analysis. The three matrices will be CP, CPK, and sigma level. So CP is potential capability, CPK is achieved capability, and from that CPK value, we can also calculate the sigma level. So at the end of the measure phase, we would have arrived at the baseline performance of the CTQ metric and would have also calculated the baseline sigma level. And the analyze phase, we will brainstorm for probable causes, construct all these causes in a pictorial format under various categories called cause and effect diagram. And then we will perform 5-by analysis to identify the root cause for a given high-level cause. Then we will prioritize the vital few causes by performing Pareto analysis or control impact matrix or subject to multi-voting. And then we will validate the significance of these vital few causes with respect to the business problem by performing testing of hypothesis. So since sample data analysis will be an integral part of testing of hypothesis, we also looked at the basic sampling concepts. So the three commonly used sampling methodologies: simple random sampling, stratified random sampling, and systematic sampling. And we also looked at how to determine the appropriate sample size. Under testing of hypothesis, we understood what is null, what is alternate hypothesis, and we also learned how to frame the null and alternate hypothesis statements for some different scenarios. And then we also looked at the sampling errors that can be associated with a hypothesis testing exercise. So alpha error or type 1 error, beta error or type 2 error. Then we looked at what is confidence level and confidence interval or margin of error. And then we kind of looked at the various sample and population notations for the statistical matrices. Then we looked at the list of hypothesis tests that we have for all these statistical matrices. Then we understood about what exactly is p-value and what is the significance of 0.05 as the criteria for p-value. And then we looked at scatter plot, which would help us to establish the relationship between the identified cause and the business problem in a pictorial format. And then we looked at correlation analysis in order to objectively measure the strength of the linear relationship between these two variables. And then we will perform the regression analysis in order to derive the regression model in the format y is equal to f of x plus epsilon. So at the end of the analyze phase, we will have the list of vital few causes, which has a huge impact on the business problem. So in the improve phase, we would be implementing the solutions, right, to attack these vital few causes. And then we'll be using Pew matrix and effort versus benefit matrix to prioritize the solutions. And we also looked at the applicability of FMEA, failure mode and effect analysis, which is the tool that we are supposed to use for identifying the risks associated with the various improved process steps. And then we moved on to the control phase, wherein we understood that control charts invented by Walter Sheward. And then control charts, the primary objective is to identify the presence of special or assignable cost variation acting on the process. And then we also looked at how the control chart would appear. So control chart will not only have the average line, but also the control limits. And we also understood that the specification limits are totally different from the control limits. While the specification limits will be given by the customer, the control limits will be derived through the process performance. So upper control limit will be average plus 3 times the standard deviation, and the lower control limit will be average minus 3 times the standard deviation, right? And there can be a question on this. So they will ask you whether the control limits and specification limits are one and the same. So we need to pick false as the correct option. And then we looked at the various rules that can be applied, or the 8 rules that we can apply for identifying the special cause or assignable cause variation in a control chart. Then we looked at the various control charts applicable for continuous data as well as for discrete data. So continuous data is also referred as variable data, and the variable control charts are IMR chart if the production rate is very, very low and we don't have enough data points to form a subgroup. And then the subgroup control charts are X bar R chart and the X bar S chart. So the X bar range chart can be applied if the subgroup sample size is 6 or less than 6. But then if the subgroup sample size is greater than 6, then we need to apply X bar standard deviation chart. And then the count discrete or the discrete data control charts. So we have the control charts for binary discrete data, which are defectives type of data. So we have NP chart for constant sample size, or if the sample size is given as being in a standard format. And then we have P chart, which is for varying sample size, or if the sample size is a percentage value of the overall production. Then for count discrete control charts, wherein we would plot defects type of data. So we have C chart for constant sample size, or if the sample size is in a standard format, and we have U chart for a varying sample size, or if the sample size is a percentage value of the overall production, right? So these are the various concepts that we actually saw during this 10 days of training. So tomorrow and day after, as I told you, we'll be looking at the Blackwell specific curriculum. So let me just share my screen and I will show you how to handle all these exercises that are likely to come as questions in the Greenbelt final assessment. So let us go to the first sheet in the exercise file, or we will look at the template reference and then go to the appropriate templates. So the template reference will be the final sheet in the exercise file. So if you look at the first scenario, wherein we would be asked to calculate the interquartile range or the outlier limit on the lower side or the outlier limit on the upper side, the Q0 and Q4 values, and they would have provided a data set, right? If this is the scenario, then we need to use the template under exercise number 2, the descriptive statistic sheet. Just click on that link. It will take you to the place where the template is stored. So we just need to provide the input values here, right? In this input data column. That's it. We don't have to really arrange this in an ascending order. We just need to provide the input values, the same sequence as it is given in the question. That's it. So moment we provide all these input values, you can see the answers populating in the output section. So you can just pick the appropriate metric which you have been asked to calculate. So if it is Q4 which you are supposed to calculate, then you can pick the value as 33. Or if you are asked to calculate IQR, then we need to pick the value as 12. Right? And there can be a question with regard to identification of the percentage of data points that would lie beyond Q3. So we know in the box whisker plot, we will have 25% of the data points that would lie beyond Q3. So that is the correct answer for this question. And then you will be asked to perform the roll throughput yield calculation. So they would have given the throughput yield values or the first pass yield values in percentage. So what we need to do, as I told you, we need to convert those percentage values in terms of decimals and simply multiply them to arrive at the roll throughput yield in decimal, and that decimal RTY value can be converted in terms of percentage. But then if you are using this template, which is given right here, so we simply need to provide the decimal throughput yield values in this template and get the answer for RTY as a percentage value, right? And then going back to the template reference sheet. So this is the second exercise, this list. The third one is the normal distribution exercise. So I can get multiple questions pertaining to this in the final assessment. So you'll be provided with mean, standard deviation, and also the specification limits. And you'll be asked to calculate either the sigma level or the yield percentage or the defect percentage. So in that case, we need to use the template given in the normal sheet, right? So under these exercises that we solve for normal distribution. So this is a normal distribution template. So you need to provide the input values here, this input section. So mean, standard deviation, and the LSL and USL values. So both LSL and USL will be provided only for nominal the better kind of metric. So if it is higher the better kind of metric, then we will have only LSL, which will be provided in the question. So we need to update only the LSL value in this template as well. So we can leave the USL field blank, but then you should not forget to choose the appropriate option from this drop down. The next column, you will have the drop down. So you should not forget to choose the appropriate option from this drop down. So both LSL and USL values are given to you. Then we need to choose the option both LSL and USL. But if only LSL is provided for higher the better kind of metric, so we need to choose the option only LSL. Then only you'll get the correct answers in the output section. So you can just pick the answers from here. So yield rate is 0.9522 for this scenario. So in terms of percentage, this will be 95.22%. So in the multiple choice, you would be provided with the percentage values for both yield as well as for defect. So we need to convert these decimal values in terms of percentage and then pick the right option. Or if you are asked to calculate the sigma level, so the answer is there in the final column, the output section. Then moving on. So the next one would be process capability analysis for discrete data, right? So wherein you'll be provided with number of defects, number of samples audited, and number of opportunities per unit sample. Or they can combine number of samples audited and number of opportunities per unit sample and express it as total number of opportunities, right? So in those exercises, they would have given only the number of defects and total number of opportunities. So whether they have given it as number of samples audited and number of opportunities per sample unit, or they had actually merged these two matrices and provided the total number of opportunities, we need to use the template given under exercise number 1, the PC discrete sheet. So wherein we just need to update all these input values. So number of defects will anyway be there. And if the combined numbers are given for total number of opportunities, then we need to leave the number of samples audited field blank and update that total value under number of opportunities. But then if they had given you the split with regard to number of samples audited and number of opportunities per unit sample, then we can fill in all the three fields and get the answer for sigma level. Or if they ask you to calculate the defect percentage, then this can be converted and expressed in terms of a percentage value. Or if they want you to calculate the yield percentage, then this accuracy rate can be converted in terms of percentage value, right? Or if they had given the sigma level and they ask you to calculate the defect percentage, then the template under exercise 2 needs to be applied. So wherein we just need to provide the sigma level. So in the question itself, they would have provided just the sigma level alone, and they would have asked you to calculate the defect percentage. If that is the case, just provide the sigma level alone in this template under exercise number 2 in PC discrete sheet, right? So you'll get the answers. So yield, if they want you to calculate the yield percentage, then we need to express this as a percentage value. So 0.9591 will be written as 95.91%. Or if they want you to calculate the defect percentage, then we need to express 0.0409 in terms of percentage value. So 0.0409 will be expressed as 4.09%. Or if they want you to find the number of opportunities that would lie outside the customer specification limits, then we need to pick this DPMO value, which is given in the third column in the output section in this template, right? Or you can get a scenario wherein they would have provided you with the DPMO value and they will ask you to calculate the sigma level. So we all know that the sigma level can be calculated only with the help of DPO value. So that being the case, we need to first convert the DPMO value in terms of DPO and then, apply the Excel formula to calculate the sigma level. So that is how we would perform the calculation. But then if you're using the template, just provide the DPMO value alone in this template. You will get to see the DPO value as well as the sigma level. So the appropriate sigma level can be chosen from the multiple choice. Right? So the template references are provided even for these type of problems in the template reference sheet. So as we can see, so the template references are provided even for the defect percentage calculation, the yield percentage calculation given the sigma level, right? So how to calculate the defect percentage or the yield percentage. And given the DPMO value, how to calculate the sigma level. So that will be the template given under exercise number 3 in PC discrete sheet in the exercise file, right? Or if you are asked to calculate the CP/CPK values, right? So given the mean, standard deviation, and the specification limits, if you are asked to calculate the CP, CPK, and sigma level values, then we need to use the template given in PC continuous sheet. But then this is the same as the normal distribution template. The same template will be used for calculating the CP and CPK values as well. So, but then I have given the same template in this PC continuous sheet as well. So you can either use the sheet given in the normal or the template given in the normal sheet, or you can use this template given in PC continuous sheet. This is the same template, normal distribution template. So you need to provide all these input values, which will be similar to our normal distribution exercises. And here, when it comes to a process capability for continuous data, you'll be asked to calculate CP or CPK value. In that case, you can use the same normal distribution template and get the answer. Then going back to the template reference, right? You'll also be asked questions with regard to sample size determination. So sample size determination for a continuous data scenario. So you will be provided with the standard deviation, which will be the historical performance metric that will be provided for a continuous data scenario. And you'll also be provided with the confidence level and margin of error. So you just need to update all these input values as given in the question in our template, right? You don't have to really calculate anything here. So you just need to provide all these input values as given in the question. So you'll be asked to calculate the sample size for this continuous data scenario. So you need to use the template given under exercise number 1 in the sample size sheet, right? Template given under exercise number 1 in the sample size sheet. So you just need to update the value as given in the question. So confidence level is 95%. We need to update it as 0.95. So whenever you use the template, right? So any percentage value that is provided as input value in the question, that has to be converted in terms of decimal value and then updated in the template. So you should not be straight away updating the percentage value in the template. So all these percentage values needs to be converted in terms of decimals and then updated in the template. So you should not forget that. So 95% confidence level will be written as 0.95 and the margin of error is anyway given as 0.02. Standard deviation is 0.25. So provide all these three input values, you will get to see the sample size, right? So as I told you, so some of the instances, if the sample size is a decimal value, then they would have rounded it off to the next highest value, right? So 600.25 would be rounded off to 601. But then here we have rounded it off to the nearest whole number. So 600.25 would be rounded off to 600. And only if it is 600.75 or whatever, it will be rounded off to 601, right? So that is the logic that we have applied here. But then in some of the places, they would have applied a different logic. So moment, you find a decimal value for the sample size calculation, they would have rounded it off to the next highest value because sample size is a discrete value. So 600 or 601, both are correct answers for this particular case scenario. So if 601 is given as one of the option in the multiple choice, you can pick that as the correct option without any hesitation. So as I told you, because of the rounding of error, so there could be a difference of plus or minus 1, right? So we need to be aware of this fact. So whichever value is closer to the answer that you see in the output section can be picked as the right answer. And as I told you, the difference will not be greater than 1, plus or minus 1, right? We need to understand. Again, if it is a discrete data scenario, or specifically binary discrete scenario, then the historical performance would be provided in terms of the defective rate, right? So in that case, you will be provided with the confidence level along with the margin of error. Both will be percentage values for discrete scenario. And the historical proportion of defectives also would have been given in the problem as a percentage value. So all those percentage values needs to be converted and expressed in terms of decimals in this template. And then you will get the sample size. And the third format could be a scenario wherein the historical performance is not known because it is a new process. So the historical performance of the process is not known because it is a new process. And you'll be asked to estimate the sample size just by providing the confidence level and the margin of error. That is the case, you don't have to really worry about the logic that we are supposed to apply. So if you're using the template, you just need to provide the confidence level and the margin of error values alone in decimals. You will get to see the sample size calculated for this scenario where the historical performance is not known to you, right? So these are the problems that you can get as questions in the Greenbelt final assessment. And the template reference sheet, as I told you, has the link for all these templates, right? You can just make use of this. You just click on the link, it will take you to the place where the template is stored, right? So rest of the things will be black belt specific curriculum, so which we will see tomorrow and day after. Any question? Things are clear?
Yes, clear.
Yes, sir.
All set to go
Yeah.
for the Greenbelt final assessment?
Yes.
Good. So let me just share the updated files with you. I will also send you the procedure once again to access the final assessment link. So the same procedure that we followed yesterday. Anyway, I will send that once again. and I will also send the updated files to you. Fine. I have sent both the updated files to the common WhatsApp group. So you can simply download them and then you can start answering the green belt final assessment questions. Right? So all the very best to each one of you. So those who are directly enrolled for the black belt certification, if they want, they can exit now and they can join for the 11th day training session tomorrow evening at the same time. And those who plan to take the green belt final assessment now can actually start the assessment, right? So I will go on mute, but I will be remaining online for the next 60 minutes or so. So in case of any clarifications required, you can always connect with me. So all the very best once again. Please do well. And once you complete the assessment, please do let me know and then you can exit. Okay? All the very best.
Sure. Thank you, Sridhar. I exit from this meeting.
Yeah. Thank you.
Thank you.
Thank you, Sridhar.
Thank you.
After it's done, can we leave?
Hello?
Yes, please.
Yeah, I'm done with it, sir.
Okay. Yeah. Connect tomorrow. Thank you.
Okay. Okay. Thank you. Good night.
Thank you. Good night.
I'm also done.
Okay. Thank you. Connect tomorrow.
Thank you. Good night.
Thank you. Good night.
Sridhar, I'm done with the exam assessment. Thank you.
Yeah. Good. Thank you. We'll connect tomorrow night.
Yeah, thanks. Good night. Bye.
Hello, sir.
Yes,
Can I repeat the test later?
Yeah, you can reset and then repeat the test later.
Okay, sir. Thank you.
Okay,
Because
thank
I
you.
couldn't finish only 25
Oh, okay.
questions I answered.
Okay, no
Yeah.
issues. You can attempt
Okay,
it
sir.
once
Thank
again.
you.
Okay. All the best. Thank you. Bye.
Okay. Thank you. Thank you. Bye. Good night, sir.
Bye.